Telescopes, seeing beyond the stars. Look up at the night sky. Right now, at this very moment, light is falling on your eyes that left its source hundreds, thousands, even billions of years ago. You don't need any equipment to see it. But if you want to see more, you need a telescope. Here's the thing. Not all telescopes are the same. Some fit in your backpack. Some are the size of a football stadium. Some fly in space, hundreds of kilometers above your head. And each one was built to answer a different question about the universe. Let's go on a tour, from the telescope you could build this weekend, all the way to the ones changing what we know about the Big Bang. Start small. Grab 2 magnifying lenses, one bigger, one smaller. Line them up inside a cardboard tube, and you've basically built what Galileo Galilei used in 1609. That's a refracting telescope. It bends light using curved glass lenses to make faraway things look close. You don't even need to buy anything fancy. A cheap 50mm beginner telescope, the kind that costs about as much as a video game, can already show you Saturn's rings and Jupiter's 4 biggest moons. The same moons Galileo discovered over 400 years ago, just by looking up. Why does this matter? Because every telescope you're about to learn about, the giant ones, the space-based ones, is doing the exact same basic job as your backyard telescope. It's just collecting way more light from way farther away. Now let's go big. Really big. In the mountains of Guizhou Province in southwest China sits FAST, the 500-meter aperture spherical telescope. It's a radio telescope, which means instead of collecting visible light like your eyes do, it collects radio waves, invisible signals that travel across the universe. Picture a dish half a kilometer wide built into a natural valley in the mountains. It's the largest single-dish radio telescope on Earth, and it's been fully running since January 2020. Since then, it's found more than 900 pulsars, fast-spinning neutron stars that flash like cosmic lighthouses. It even helped scientists gather evidence that some mysterious cosmic flashes called fast radio bursts might come from pairs of stars orbiting each other, a discovery published just this January. FAST is still very much active. Engineers even upgraded some of its cables in 2026 to keep it running for years to come, and China is adding 24 more dishes around it to make it even more powerful. You might also hear about Arecibo Observatory in Puerto Rico. For decades, it was the world's biggest radio dish, and it helped scientists send the first message ever beamed deliberately into deep space. Sadly, its structure collapsed in 2020 after cables failed, so Arecibo is no longer operating. That's part of why FAST matters so much now. It picked up where Arecibo left off. Here's a question. What if you could put a telescope above the atmosphere entirely, so clouds, city lights, and blurry air never got in the way? That's exactly what engineers did with the Hubble Space Telescope. Hubble orbits about 535 kilometers above Earth. That's called low Earth orbit, the same general zone the International Space Station flies in. Launched in 1990, Hubble has now been working for over 3 decades, and it's still active today. Hubble is the reason you've probably seen those famous glowing, colorful pillars of gas photos. The pillars of creation. It helped scientists figure out how fast the universe is expanding. It found moons around Pluto. It's taken more than 1.5 million observations. And because it flies in low orbit, astronauts could actually visit it with a space shuttle to repair and upgrade it 5 separate times, something you could never do with a telescope stationed farther out. Now you asked a great question. Is there a telescope way out in geostationary orbit? The spot about 36,000 kilometers up, where satellites orbit at the same speed Earth spins? so they seem to hang over one fixed point? Here's the honest answer. No major astronomy telescope actually sits there. That orbit is perfect for weather satellites and TV/communication satellites that need to stay locked over one spot on Earth. But for deep space astronomy, scientists usually choose one of two very different spots instead. Close to Earth, like Hubble, so it's easier to build, launch, and even repair. Or far from Earth, at a special gravity-balanced parking spot, which is exactly where our next telescope lives. Meet the James Webb Space Telescope, or JWST. Unlike Hubble, Webb doesn't orbit Earth closely at all. It sits at a location called the second Lagrange point, about 1.5 million kilometers away, roughly 4 times farther than the Moon. Out there, Earth, the Sun, and Webb stay lined up together, letting Webb's giant sunshield, about the size of a tennis court, block heat from both the Sun and Earth at once, so its instruments stay incredibly cold and can detect the faint infrared glow of the earliest galaxies. Webb launched in December 2021 and has been fully operating since July 2022, and it is still very active right now. Since then, it has completely shaken up astronomy. It has spotted impossibly early, surprisingly massive and structured galaxies from just a few 100 million years after the Big Bang, findings that are forcing scientists to rethink how galaxies formed so fast. It has studied the atmospheres of dozens of distant exoplanets, including possible chemical clues on a planet called K2-18b, though scientists are still working to confirm exactly what they mean. It even spotted a brand new moon around Uranus in 2025 and studied a rare interstellar comet called 3I Atlas, passing through our solar system in 2026. Because Webb is so far from Earth, there's no repair mission possible like there was for Hubble. Everything had to work perfectly the first time. So far, it has. One more stop before we finish. Back down on Earth's surface, high in the mountains of Chile, sits the brand new Vera C. Rubin Observatory. Its telescope has an 8.4-meter mirror and is paired with the world's largest digital camera, so big that a single full-size photo would need about 400 ultra-high-definition TV screens just to display it at full size. Rubin released its first images in June 2025 and has just begun its main job, photographing the entire southern night sky over and over again, every few nights, for 10 straight years. Scientists call this the legacy survey of space and time. In just its first 10 hours of test images, Rubin had already spotted millions of galaxies and stars and thousands of asteroids. Its real mission, creating the biggest time-lapse movie of the universe ever made, catching exploding stars and asteroids the instant they change, began in early 2026, and it's running right now. So here's what you've just traveled through. A cardboard tube with 2 lenses in your hands, a dish half a kilometer wide buried in a Chinese valley, a telescope skimming low Earth orbit close enough for astronauts to fix by hand, one parked 1.5 million kilometers out where it's cold enough to see the first galaxies ever formed, and a brand new camera in the Chilean mountains about to film the universe like a movie for the next 10 years. Every single one of these instruments is doing the same basic thing your eyes do, catching light. Just far more of it, from far farther away. And the telescope you build this weekend out of a cardboard tube, it works on the exact same principle as every one of them. The universe has been sending light toward Earth for billions of years. The only question left is, what are you going to look at first? The universe is waiting for you.